Good.
All right.
Let's see. Okay. Okay, wait. Record discuss distribution applet. Okay, we're gonna need the T distribution applet. And
Are we
then
recording now, Katie?
yes, we are.
Okay. All righty. Who wants to lead this one?
I can read it. Suppose we have a set of paired data and that d equal x after minus x before. The null hypothesis is h0 whatever. I haven't mu d equals 0. The alternative hypothesis is h alpha mu d does not equal 0, and the population standard deviation is not known. Jordan collects a sample size of 9 and computes d 2.2 s 3.3. What is the value of the test statistic?
The statistic. Okay. Let's see.
I am working on about 2 hours of sleep, so I'm sorry ahead of time.
So the formula for that one is T equals the D bar minus 0 over the standard deviation of the difference divided by the square of the.
Can you what? Yeah. Can you say that again?
It's T equals
yeah.
The D bar minus 0 divided by the standard deviation of the difference divided by the square root of the number.
So the standard deviation of the difference is the SD?
Yeah. So it's 2.2 minus 0 divided by 3.3 divided by square root of 9.
Yeah, got it. Okay.
Moses, did you do this one already?
Yeah, I did it. I got 5 wrong, but I got this one right. It's 2, right?
Yeah.
Yeah,
it's 2.
Yeah, T value.
I think I missed 4 on this one.
I missed 4. Yeah, I missed 4 too.
Did you? The last one. So I went over with him so he could show me what I did wrong. Did you want to keep reading, Lance?
So what's the answer, 2 or 4?
4. The number 3, the answer is 2.
It's 2, right? Okay.
Bless you. Yeah.
Sorry. That's what. Okay. Yeah, I can read. So the next one is the probability of obtaining a test statistic greater than Jordan's test statistic is. Oh man, I think I'm allergic to something in this place. Is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test. Round to 3 decimal places. So, okay. So you do the t-value or t-score, z-score, whatever thing, and then use the probability applet, right?
Let me see.
Is that what it is? Just the probability applet? Oh. I didn't get this one. I think you're right.
Yeah. So I put in 2. So the degrees of freedom were 8 at the top. And then the T at the bottom was 2. And you shade to the right and the left. And then they wanted it to be at 3 decimal points. So it was 0.081. I don't know what those other numbers had to do with anything. I think that was just to confuse us. Because I did 0.081 and I got it right.
0.081.
Yeah. I have no idea what, because I sat there for a long time trying to figure out what is 0.0403 have to do with anything. And I just ignored it finally and just did whatever. I put the 2 for the T and then did the degree of freedom 8 because the sample size was 9 and I got the 0.081 and it was right.
So you did degree of freedom 8 and then just put -2 at the bottom and it ignored the area thing?
I shaded the right and the left and I put a +2 on the right hand
the area
side.
comes out as 0.0805.
Yeah.
Okay. Yep.
So what do you put in the area? Nothing?
No, you don't put anything in the area because that's what you're trying to figure out is the probability.
Yes, so on the below you put -2 and +2, and the width, the degree of freedom.
Where do you get the degree of freedom from? How do you get the 8?
Because the degree of freedom is the sample size -1.
Oh, okay.
Okay.
N -1, and so that would be 8.
Yeah.
Oh, yeah, because it's N9, right?
Yeah, yeah.
Yes, so you get 0.0805, right? But you round.
Yes.
And decimal source.
So
Okay.
degree of
Yeah.
freedom formula is N minus 1?
Yes.
Okay.
Okay.
And then the next one we have to open up that group.
Yeah, the Excel.
Yeah, the Excel.
Right, yeah, I know. I don't know what there is something that I need to do with this Excel.
And that's I got it wrong the first time, but I think it's the T-score, right? On the same as the other question. It's just the T-score, the T value, or whatever it's called.
The test statistic is actually the mean. Wait. I think I'm mixing it up. No, yes, you're right. The test statistic is the T.
So are we doing group 1 minus group 2, blah, blah, blah. So what is the test statistic? So is that the averages of all of them?
No, Salu.
Gracias.
You have to take those numbers and you have to put them in the wait, hold on, where am I at? The paired sample t-test. On the quantitative inference, the bottom, it says one sample t-test, paired sample t-test. It's the paired sample t-test. You see what I'm talking about?
I have to open that quantitative descriptive statistics thing or
Yeah,
inference.
I cannot open it. This Excel. Just
my
keep going.
computer's dragging here. This internet is so slow, and I'm trying to open it.
Do you want me to share my screen?
I will really appreciate that.
It's the inference one, right? We're supposed to be opening that quantitative inference procedures, right?
Yeah.
Yeah. Well, mine's not opening.
Okay, so let me see if I can do it. So I emptied all mine out first because it never does it right like it's supposed to. And then go to group 1, and I'm going to copy these and then go back to my spreadsheet and I'm going to put it in there. And then I want this one to equal this minus this enter. And then I'm just going to copy and paste all this. I just learned how to do that this week. I'm so proud of myself. I don't even know what to do with myself. There we go. Okay, so then can you see that where it's now we're not paying attention to these two. It's just to the difference. So the difference here, the t-score is going to be the 0.407. And you just get that directly off that paper. So
0.407 is the answer.
Yeah, 0.407. Is that what you got, Moses, too?
Yes, 0.47.
And then you go back and that same thing, and it's going to tell you what the p-value is.
P-value. Yeah.
Oh, but you know what? I need to make sure first. Moses, you're not stopping me. Was it a 0.95 we were checking out? No, it was a 0.90.
Yeah, 0.9.
0.90 because we are looking for an alpha of 0.10. I need to change this to, whoops, wrong one.
Oh, I didn't change anything on that. We're supposed to do that?
0.90. Well, just because you're supposed to make that confidence level the same. But then also I didn't change.
Maybe that's why I got one of them wrong.
And then this right here where it's the not equal to, you got to make sure that it says that it is not equal to right here. So see that now it changed, and that only changes the p-value. So the p-value is going to be 0.689. If that was, I messed up a couple of times because I didn't change the 0.689. I didn't change it like it was supposed to be. I have to go back and check myself again. And then if the p-value is greater than the 0.10 and it was 0.6, so it was higher than we failed to reject. You guys, if you don't agree with me, then tell me, because
that is correct, yeah. 7 is failed to reject.
And then now it says, suppose that your alternate hypothesis. So right here, they want us to change it from the not equal to, we're going to change it to the greater than. And then the p-value, if you watch it, it's going to change. And so when we go back to this, now they want to know, okay, now we got to look at what the p-value is and see if it's above the 0.10. And that's 3.44. 3.45. So then we're going to reject the null hypothesis. I mean, we're going to fail to reject the null hypothesis because it's greater than. And so I know that we have sufficient evidence. Wait. We have insufficient evidence because we're trying to disprove the alternate hypothesis. So then we would have insufficient evidence that the mean of the difference is greater than 0. Do you guys see where that is?
Yeah.
The 0.345 is bigger than the 0.10.
So we failed to reject, right?
Yeah, we failed to reject.
It's not what the alternatives is telling us.
Yeah, exactly. So we don't have evidence that the alternative is correct.
Okay.
And then the next one, we have to go in there and clean it out again. All of this. And we go to the other one and copy and paste this. And then we want to do the same thing with the equal. It's 1 minus the 2. And then equal.
What number are we on?
9.
Number 9, I think.
Yes, number 9.
Yeah. Okay.
We are finding out which one is greater, N or DF.
And then the N is 22, and then the degree of freedom is 21 because it's the N
21.
minus 1.
Uh-huh.
So they want to
So
know.
N is greater?
Yeah.
So the confidence level, you change it to 99, or what do you change it to?
Let me see. I didn't even look yet. Yeah, I'm going to change it to 99 and leave it at the not equal to. Well, I got to put it back to not equal to now because I changed it to greater than. So not equal to, and then 0.99. And it doesn't change the N or the degree of freedom. So those, it just always changes the p-value and the confidence interval.
Yeah.
And so number 9 was that the sample size is bigger, and then they want to know what the p-value is. Okay. And so that's right here, this one.
0.001.
Yes.
Hey, my quantitative inference thing just finally opened.
Woo! It's so much. I understand it better when I'm looking at it and not just following along. So with the 0.99, we wanted to know if the p-value is going to be above 0.01. And here's the p-value right here. The 0.001. So it doesn't, so we reject it.
Reject the no. Did I miss number 10 then?
Yes, it's 0.001. Is the amount Pauline is showing on the screen.
Because I'm having to try to follow along Pauline's thing on my iPhone since I don't have the full screen here. So.
Oh, yeah. The
you see the p-value?
I can barely read what you're doing.
Did you put in like an?
Do what, Katie?
Oh no, just go ahead. I was trying to tell Lance maybe he can move herself like another position. It shows a little bit bigger, but it's okay.
Oh.
Just go ahead.
So 10 is the 0.001.
Yeah.
And then 11
has failed to reject the null hypothesis.
Yes. And then 12. What is the question? I don't even know what the question is.
You decide to try another alternative hypothesis. This time you use H alpha mu is greater than 0, and you keep the same level of significance. Did the p-value increase or decrease?
Okay, so all we're simply doing is going right here and changing this to greater than. And
greater
then
than?
Yeah, just watch the p-value. It'll change to 0.0006.
So it decreased?
So it decreases.
Yes. And then, so what decision do you make if it's 0.0006 and you want it to be 0.01 or greater? If it's not as big as the 0.01, then you reject it.
Yeah.
Right.
And so that one was rejected. And then based on your response from the previous conclusion, what do you make? So,
we have sufficient evidence that there is a mean difference between the two groups.
Yes.
Right?
Mm-hmm.
Yeah, we have sufficient evidence that there is a mean difference between two different groups.
We have sufficient.
But no, determine, what was that? What number was that? Yeah, we have sufficient evidence that there was no mean difference between the two groups. Okay, yeah. I just want to make sure that I was getting the answers right this time because I missed a couple of these ones. And then what's the next question?
As we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value? My thought is the last one, but I don't know why. So,
but it will depend on how much, right? We will need to have more information, for this.
Yeah, well, that's what I missed. That was one that I missed. And when I asked him, he said, yeah, we don't have enough information.
oh, okay.
Because I was thinking the same thing as Lance.
Yeah, me too. I missed that one too. Until right now, I thought about
it. That's what I get for thinking.
And then what is the point estimate for the 95% confidence interval? Point estimate. That's the D bar. That one confused me. So the D bar is the mean right here.
Mm-hmm.
So it's the 11.955. And you just have to get that off of the Excel.
Oh, okay.
So on the Excel, you just change that to 95%.
Oh yeah, sorry about that. Yes, you're right. 95%.
the same answer.
And then it's this one right here. And the only thing that I've been watching it, the only thing that changes when you change this right here is the p-value and the
p-value.
Okay.
Okay. Yeah.
And then the margin of error for this 95% confidence interval. Okay.
Yeah.
This one I missed too. This one, it was, and he kind of told me a trick, which I think I was doing it already, but I wasn't sure that I was supposed to be, is if you take this 18.607 and minus the 5.303, and then if you divide it by 2, then you know what margin of error that you're adding to the 11.955.
What is it? 7.5? I don't know. I don't even get that one.
So you do the 18 point something.
18.607.
Oh.
Minus
5.303. Just the difference of that.
And then you're gonna half that because half of it's gonna go here and half of it's gonna go here, and this right here is what this mean is.
So is it gonna be 7 point something?
I got 6.652. Did anybody else do it on the calculator?
I did it through Excel and I got the same thing as you, Pauline.
And he actually showed me a really cool thing to do. Lance, I know you're familiar with this, but I'm not. And so he showed me the formula to put it in. That's why I get this 6.652. He just told me to put an equal sign with a
parentheses.
Yeah. And then the 2.08. And I got the 2.08. Oh, I don't know. Never mind. It's too involved.
Yeah, I could do that in Excel.
Yeah, it was from, he had showed me how to go up to the student's probability and put in the degrees of freedom. Whoops. The degrees of freedom, which was 21, and then put in 0.05 because I've got the shaded outside here. I don't know why. If you shade the inside, then you do without the two sides, then you do 0.95 in the middle. But if you either way, it doesn't matter. But you come out with that 2.080 or 2.080. That's the T. They don't call this the T-score. He said they just call it the T. And so if you went into the Excel and see how I did the equal sign parenthesis 2.08, that's what I got from that app. And then I do the asterisk and then touch on the mean because that's the formula. It's the when we were talking about it earlier, that was the formula that we were saying that margin of error was the T asterisk SD over the square root square. What am I saying? Square root of n. That's the formula right there in Excel, and it gives me the same answer as the what we came up with if we subtracted these and then divided them by 2.
Yeah.
6.653. Anyway, I thought it was kind of neat because I didn't know what that was. And then here
Well,
they
you
get
got to take. You're gonna have to take the advanced, spreadsheet analysis class. I know you will, and you're gonna.
Yeah, I'm right on that, Lance.
And anything you ever and never wanted to know about Excel.
Well, I think it's neat. I didn't know all this stuff, so that's pretty cool.
It's very powerful.
Yeah, it is. I'm like, it figured it out for me. I didn't even have to do it.
Yeah.
So it wants to know what the lower level of the confidence level is now, and so that would be this number right here.
Pauline, one more time about the formula for the margin of error is, because I have one right here on one of my flashcards. I got margin of error m equals z score times standard deviation divided by the square root of n.
Yes, that's the confidence interval when we know what the sigma is. But on the paired sample t-test, we don't know what the sigma is, what the standard deviation is.
So what is the formula?
So it's T instead of Z. T like in Tom.
Okay. T times?
T times the SD, the standard deviation of the difference.
Standard deviation of the difference. Okay.
Divided by the N. Same thing, it's just a T instead of a Z.
Okay.
And we get that T from putting that up here like that. Mm-hmm. You have to put the degrees of freedom and you have to put the area. And if you shade this area, you put the 0.95. And then if you shade these outside areas and not the middle, then it's 0.5. And it comes up with the same answer either way. It doesn't matter.
Okay. All right. Yeah.
And so then what are we on? We're on the low bound, the lower bound. So that was 5.303.
Yeah.
5.303.
And then the upper bound is the 18.607.
Yep. That what it is 18.607.
Yeah.
Okay. And then are we done?
I think so. I'm submitting.
Somebody want to submit it first? Because this is my second try.
Pauline, you rock. That's 100%.
Okay, cool. Alrighty. That was a fast. Well, we're getting faster.
Yeah, so we're going to meet again tomorrow, and I actually am going to have time to be a little more prepared. Today was an absolute nightmare.
Please.
I was at the airport for 3 hours after we landed dealing with the rental car.
Fun.
Nobody had returned rental cars, and so we were sitting there waiting for one to be returned. Oh,
well, yeah, I'm going to get a tutor right before